In this video, we're going to look at proofs with special line segments. So we're going to look at triangle proofs just like we looked at before, but now we have some other givens using our vocab about special line segments. So if you look at our givens in this first example here, it says that we have a median. So you want to think about a median. What is a median of a triangle? So CE is the median of this triangle, which means that E would have to be the midpoint because medians connect from the vertex to the midpoint of the opposite side. And if E is a midpoint, well, that makes these two parts here, DE and EF, congruent. So that's important. And then this other stuff here, angle D and angle F are congruent. Angle DEC, so DEC and FEC, those are also congruent. And my goal here is to just prove that triangle CDE, so CDE, I want to prove that that's congruent to triangle CFE. So again, when we're thinking about proving congruent triangles, we're thinking about our 5 methods. We have side, 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 angle, side, angle, side, angle, 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 side, and HL. So when I think about these, well, I already have angle, side, angle based on what I marked. So that's the way that I'm going to go about proving this. But I also think if I were to mark the reflexive property, which you might be thinking, could you mark it? And absolutely you could. Then you could do side, angle, side. So this could be a possibility. You could do angle, angle, side as a possibility. So there's lots of options here. But for the sake of the givens that are here, I'm going to go ahead and use angle, side, angle. So what I'm going to do is I'm going to write down my givens here. So I have CE is a median of CDF. So this was given. And then I have angle D is congruent to angle F. And then angle DEC is congruent to angle FEC. And then really, if I'm using angle, side, angle, I already have my 2 angles right here. So the only thing I need to talk about are the sides, and that comes from the median. So remember what we first said, since CE is a median, that means that E is the midpoint. So I'm going to go ahead and make that conclusion. I'm going to say E is the midpoint of DF. And that's because a median connects the vertex and midpoint of a triangle. So then since I had a midpoint, that allowed me to say DE is congruent to FE because midpoints imply 2 congruent segments. So essentially, I wrote out 2 steps here, but essentially I'm just saying if you have a median, well, then you're always going to get the 2 congruent segments because medians always connect to midpoints. So that's what I have as my last piece here. So there's my side. So now I can connect these 3 pieces to say that the triangles are congruent. So now I can say triangle CDE is congruent to triangle CFE. And that's by angle, side, angle. So let's try one more using these new segments. So this one says that I have an altitude. So AC is an altitude of triangle ACD, which really means it's the altitude of this entire, we're going to say that it's the altitude of this entire triangle. Because we have also BC and DC congruent, and we're trying to prove these two, these letters are messed up, huh? So let me fix this here. So we have AC is the altitude of triangle ADB. So let's make this of this big triangle. And what we're going to try to prove here, so we're going to try to prove not CDE because we don't have an E. We're going to try to prove that CDA, so CDA is congruent to CBA. Otherwise, this won't be possible. So with that said, now I'm going to go back to the beginning. AC is the altitude of A. Oops, I wrote the wrong triangle again. I meant to say ADB or A. How about we just do this? ABD. There we go. So AC is the altitude of triangle ABD. So that means that this is the height of the big triangle ABD, which means that I have right angles here at 1 and 2. Because altitudes are always perpendicular to the base. And I also know that BC is congruent to DC. And if I'm trying to prove CDA, so CDA congruent to CBA, right away I'm thinking about my 5 methods. And I only have 2 things marked in each picture, but I'm thinking about my reflexive property here. I'm thinking about that shared side. So then this would be side angle side is what I see here. So when I go to write about this, I have AC is the altitude of triangle ABD. And BC is congruent to DC. I already have in my proof, I have one of the sides, but I need to be able to get the angles on the other sides. So the other side came from the reflexive, so let's go ahead and take care of that, and then we'll deal with the altitude. So AC is congruent to AC. It's the reflexive property. And that takes care of my other side. Now I need to get those angles. So since I'm using side angle side, I need to go through the process of having perpendicular lines, which imply right angles, which imply congruent right angles, since I'm trying to use side angle side. So the fact that I have an altitude, well, I'm going to say that altitudes are perpendicular to the opposite side, or altitudes will create right angles. So I'm going to go right into that. So I'm going to go ahead and say that I have right angles. So since I have the altitude, I'm going to go ahead and kind of use this as like my perpendicular lines, gives me the right angles. So I'm going to say angle 1 and angle 2 are right angles. And that's because altitudes form right angles, or altitudes are perpendicular with the base of the triangle or with the opposite side of the triangle. So I'm going to just say altitudes imply right angles. This is probably the shortest way, but I could say altitudes are perpendicular to the opposite side and perpendicular lines make right angles. So I could add an in-between step in there that says AC is perpendicular to BD, and then just say something about the altitudes being perpendicular. But I feel like it's fine to go right in from altitude to saying, okay, well, I have right angles because anytime you have an altitude, you're going to have a right angle. And then from here, I need to say that my right angles are congruent, because all right angles are congruent, and I'm trying to find a pair of congruent corresponding angles. So all right angles are congruent. And now when I look at my proof here, this gives me what I need. This gives me the right angles and congruent, which gives me the A for side angle side. So now with all 3 of these pieces, I can say triangle CDA is congruent to triangle, CBA. And that's by side angle side. And that's it. So really the proofs are the same. It's just now we have some additional reasons that we can use within these proofs. So go ahead, write some key ideas down and try the check your understanding problems.